Hello everyone, how's it going? How's the day so far? Are you enjoying yourself? I hope this presentation is going to contribute to that feeling. If not, please blame me, not the organizers. I think the conference thus far has been pretty good. But you can blame me afterwards, you can see all my details. I still hope that you're going to enjoy it. So I am going to be talking about test-driven development applied to infrastructure, specifically to containers. And because these days a lot of things are getting built upon container technology, and Docker is a prime contender in this space, obviously. A lot of people are using it because of its versatility, because of its isolation structure, and applications that you can use, they can build with it, and that enable you to develop complex, interactive, and interconnected applications, which are also faster to deploy with little effort, not just on your production infrastructure, but also on your local laptop, for example. And in a sense, Docker is a manifestation of infrastructure as code. So you write your Docker file, which is very much expresses of what you want to do with your infrastructure in a sense, because the only thing you do is take it from one place to another, it stays the same. However, as much as we usually follow test-driven development practices when it comes to developing software, when it comes to infrastructure, and particularly containers, not many people use this approach for creating their applications. And usually it's a plug-and-pray approach, if you haven't heard that term yet. So it's you write something and you hope it works. If it doesn't, you just iterate very fast. And in the end, you end up with something which might be working in production as well. And because people usually tend to think, if it's easy to change it, why would I have to bother with writing anything around it? And that might be still appropriate for somebody hacking away on a local laptop, right? If you just create a Docker image on your local machine, that's fine. But as soon as you have to write code for containers into your infrastructure, which you have to write in a team or have to contribute to a team effort, you will probably run into problems sooner or later with this fire and forget approach, because your team will be seriously slowed down by the approach. And at this point, people usually try to establish other environments where they can test something in, like a pre-prod environment or test environment or staging environment, where you test for coherence, where you test for things that you expect this container to do, or before you deploy it into production, and until something is seemingly stable enough to be deployed into an end-user environment. But my question was, before I started this project that I'm now on, and which I'm going to report about right here, is why don't we apply the same TDD principles which we've seen before also to containers? So your regular code that you put into your Docker file, why don't you test it as well? Why don't you write unit or functional, even integration or end-to-end tests for your containers before they hit production? And what business value can you get out of it if your code is actually tested before it enters any kind of environment? What kind of money can you save? What kind of time can you save? And how can you make your team more effective? And that's what I'll try to talk about and give you some idea about today. So the first thing is, this is how you would usually test your code in production, right? You go about writing a test, which you can see here. This is RSpec in particular, and at some later point in time, you're going to write some code which is going to end up in production, will satisfy this test. And so you write it in small incremental steps, and you run your tests in between until your tests are green, and then you proceed to the next feature, the next iteration where you build on top of the test that you've established before. So as I said, this is RSpec. It's a BDD framework for Ruby. I'm going to be running a lot of Ruby samples in this one. I could have written them in Go as well, or Python or whatever. It's just that the framework that I'm going to be using is actually written in Ruby, so I opted for using some Ruby samples as well. What this does essentially is just it describes a behavior, which is the behavior of the function fizzbuzz, which is supposed to implement this fizzbuzz code. I won't show you the implementation. I reckon everybody knows what fizzbuzz is. But this would be a test which will actually qualify for a fizzbuzz implementation. Now, if we take the same approach and go towards infrastructure, how could this look? So I'm going to show you right now a test which is running on a framework which is called ServerSpec, and this is based on RSpec, which I just showed you, and Spec Infra, which is a package which holds a lot of logic for several backends and several convergence architectures, and this is essentially an implementation test for something which is a Docker file or a Docker container, which installs the Ruby package. You can TDD this exactly. So you can write this test before, and then you can run the test, and then you actually implement the Docker file which satisfies the test. And as I said before, it basically just checks if you have installed a Ruby package. And let's take a look at some of the parts that you see here in detail. So a step-by-step guide through is, the first thing is, what you do is you use the Docker API. Since Docker is a client-server architecture, you use the API from Ruby to communicate with the Docker server. And you tell it, this is my Docker file. Whatever you do within your test, it has to do with this one Docker file. And then you set for ServerSpec an option which tells it to use that specific image that you've just created with the Docker API to run the tests that you want to run. And in the end, you should just describe what you're trying to see. So in this logic, it should be installed. And this Ruby package that we're describing here, that's our expectation that we're formulating, this one should be installed with the test actually. To actually execute this test, you then run bundle install. At least that's what you usually do in Ruby world, because bundler is the Ruby package manager that you would usually use, which installs gems, which are packages in Ruby the Ruby world. And then you execute the specific test that you would actually want to execute. And I actually want to do this with you right now. I have this running on my laptop. This is actually let's just clear this for once. So I've written a very small convenience script. You will see all the code afterwards. It'll be online. Just that I don't have to actually write all of it, what I just mentioned. I'll just write go test 1, which will exactly execute the test that you've seen before. Wait, I forgot to switch the branch. So this will actually be go green now. There we go. All right. So I've written a special branch where nothing's implemented yet, obviously. So as you can see here now, first of all, you see that the first test that you see here, the Ruby test, actually fails. And then it tells you exactly what this failure entails. So it says it expected the package Ruby to be installed. And then it tells you where exactly it failed, how long the test took, and what the summary is. Unfortunately, this is kind of cut up. I think this is because of the TV adapter, but that's fine. I can tell you that this is one example, one failure, and then it basically gives you a summary at the end and then falls back. So if we're going back to what we would actually have to do to satisfy this test, as I've shown you before, this is the test, right? What would I have to do in terms of writing a Docker file? So this will be it. This is the smallest available subset that you can build. I would definitely opt for using Alpine in this case. If you haven't heard of Alpine yet, it's a brilliant Linux distribution which only is 2 megabytes in size. It comes with a full-fledged package manager which you can use for pretty much anything. And yes, it can run Java. Even though it doesn't have a dedicated Java package, but it can run Java. So all it does in this is essentially using the local package manager, got APG and APK, and it then installs the Ruby package, and that's it. No command instruction, nothing. But this actually validates our test. So if we now run, if I switch back to my terminal, and if I now run, there we go. If I now run, go back to the master and run the same test again with the Docker file in place, it'll give me back what you said, what you saw initially. So now it'll actually show me, yes, this test is green. I have one example, 0 failures. Everything is cool. So that's the kind of the first application that you've seen running in a Docker file, which was developed using test-driven development. Now, the project structure itself that you would see for this example here, and this will expand beyond just this very simple one if you actually want to write some more tests, is like this. So you have the Docker file, which in this case is the example that we just ran, and you have the gem file, which is the package definition for bundler, where you have all the packages listed that you have within your project. And then you have this spec, example1, example spec RB structure. This is what RSpec actually, or RSpec in its core actually expects the project to look like. You can structure it differently, but then you have to write some scaffolding code. So I would advise you, if you start off, just structure the project like this. There's also a little file called Spec Helper, which is directly located inside the spec folder. This essentially is something that holds all of the definitions that you run for each of the tests. So includes relevant packages, does some setup routines, and we can go through this. So first of all, I'll take a look. Let's take a look at the actual gem file. So this includes basically a couple of definitions. For example, it includes the ServerSpec package, includes the Docker API package, which we use to communicate with the Docker API. And this will this will actually make bundler install succeed, and you will have all the relevant packages installed. And then there's the Spec Helper. So the Spec Helper essentially requires all the packages that you previously installed with bundler, and then it sets specific options for ServerSpec, which tells it how to run the tests that you've formulated. In this case, it sets the backend to Docker. There are a lot of other backends which I'll get to later. And then it sets the OS family to Alpine. It can auto-detect most of the popular operating systems. For Alpine, it's not that reliable. That's why I specifically set it to Alpine here. But this could be CentOS, this could be Red Hat, this could be Ubuntu, this could be pretty much anything that you want to think of. It even supports Windows, for all those who are interested in that. So this is essentially the structure and the first test that we ran. Now, usually you don't just want to install a single package, but you actually want to do something beyond that. So let's take a look at a very simple web service. So the simplest that you can do in Ruby is actually just use a package which is called Sinatra, which is a very small web framework. And you just require it, and then you specify a URL part and the response to that URL part. In this case, we're just going to echo sample web service to whoever is going to access that application. Now, let's take a look at the test that we would have to write in order to specify a specific Docker file for this. So again, the first line is specifying where to actually build the Docker file from. So in this case, it's example 2. And then the test describes, hey, use the second image ID, and then it describes a very specific thing, which is peculiar because it actually goes into describing an API, because we're not actually building an application-specific thing, but we're actually building a web response. So, and then it uses a wait for routine. Wait for, in this case, as you can see here, is a very handy utility, which basically says poll for X number of seconds until you have a success, or fail after a certain amount of time. The default is 10 seconds, which obviously makes it easier for you to do timed things like waiting for a daemon to start up or waiting for an application to start, because you can literally specify, just stop at this point and wait for something to return you anything, and if it does, then proceed. And if it doesn't, you fail the test. And then it actually just uses a very small thing. In this case, it uses curl on the machine itself to access the application locally and match the response that it should be getting back. That is essentially the test for the Docker file that we're going to try to write. Now, if you run this test right now, let's check back to failing. If you run this test right now, it'll go like this. So in the background, it'll basically build a Docker image on the fly, and it'll then run your test. In this case, it stops at the wait for routine, because obviously there's nothing in the container yet which could possibly answer on a certain port. So that's why it fails. Both of the tests that we've written are failing. The first one, if we scroll up, the first one, it specifically says expected port to be listening, and this isn't the case. Again, with a backtrace where it exactly went wrong. And the second one is, since it obviously cannot actually match anything within an empty response, it'll just give you an error, and it'll actually tell you what the response was and what it should have been, so you can diagnose that on the fly. And in the end, the summary at the end, so this will essentially tell you, hey, now you have work to do. So I'm going to switch back to the original thing, but let's go back to our presentation. Now, what would the Docker file look like for this? Well, again, we're going to use Alpine for this, but this time we're going to add a little bit more scaffolding. So this is going to install Ruby, because Sinatra is a Ruby gem, a Ruby package. It's going to install CS certificates and Ruby JSON and curl. So this is basically just needed for the tests or Sinatra to be running within this container. And curl we're going to use as a kind of workaround to execute our test from within the container, because otherwise we would have to have some kind of routine to determine which is the IP address of the container that you're starting from within the test, since you're running it somewhere else. It can be done. You can contact me later for some code if you're interested. But for all intents and purposes, for this one, I'm going to try to keep it simple and just execute curl locally. So this essentially then adds the Sinatra application that we saw before, the RB file, to the Docker file, and then in the end has a command instruction which will just execute the file, open up a web server, and hopefully respond with the name that we just saw. So with this Docker file in place, let's go back to what I said initially. Let's execute this test. This time again, it'll build the Docker image in the background fresh, and it'll then execute the test. And as you can see here, now we're actually having something listening on the right port, and it'll answer with the right response. Summary says 0 failures. Now this is just a single image, right? You have a single set of tests, maybe even more complicated, and you have a single image, and that's fine. But most people usually, they want a more complicated setup. So why not use something like Docker Compose? Docker Compose has a direct interface which you could use from within Ruby, for example. Everything that you use within ServerSpec, you can also use, anything you want to use within ServerSpec, you can use Ruby for. So what we're going to do is, we're going to implement a web service which will be a little bit more complicated. So what this web service does is basically does the same thing as before. It's a web application using Sinatra, but in this case it's going to have a /message endpoint, and the /message endpoint will actually read a dynamic value from an attached console instance, console by HashiCorp, key value store. And what it'll do, it'll go back to this console instance for each and every request, so no caching involved or anything. It's a very simple application after all. But it'll be a connected application that you now would want to test, obviously. Now, if you would just test with one container, you would fail because this application wouldn't be responding with the right values. But if you test them in unison, you actually get something back which you can deploy afterwards directly without any further testing. So again, this is what the Docker Compose file looks like. I'm using the official console image. So this isn't the modified one. It's just the HashiCorp provides these for free on the Docker Hub. So that's it's going to run in dev mode, no authentication, whatever. You can also use authentication, obviously. It all depends how complicated you want to actually structure your tests. And then I'm going to run a Sinatra container, which I'm going to go give a specific name and use a Docker file for the third example that you see here. It'll link to the console container so they can talk to each other. And the Sinatra container will expose the same port as before, 4567. So in the end, what we're going to expect is that it'll actually respond to us. And that's what we're going to be actually formulating in our tests. So I'm going to skip the initial setup code that you saw before with the image and Docker Compose, because this is a little bit different. Because before we run all the tests, what we do is we actually start up all of the instances that we see, and we're going to get the container that console is in, and we're going to get whatever image it has, and then we're going to pre-fill console before we run our actual test on the attached Sinatra instance. So this is very important. You essentially are establishing a valid environment that might be comparable to whatever production infrastructure you have, with test data, with test values, whatever you want to do, and then you run your tests. So this gives you more confidence that whatever you're doing on production might be represented also within this container setup, within this testing infrastructure. What you do afterwards, obviously, is you tear down the infrastructure that you just started using Docker Compose. You kill all the containers, and then you force remove them, which cleans up the environment afterwards. And then, at the setup, at the very beginning of the test, obviously you tell Docker via ServerSpec which container to actually run this test in, as before. This time you're not actually using an image, but you're using a container which is already started by Docker Compose. Now let's take a look at the complete test. As I said before, I skipped the gritty parts before, but in this case, again, we're including the Spec Helper, we're including Docker Compose because we're using it. And then we're describing the third Docker container. In this case, it's a Sinatra container, as I showed you before. We're pre-filling it using the console kv command, which is the latest addition to console itself. And afterwards, we're going to tear it all down once our actual test has been run. And the test itself is actually pretty simple. That's it. So what it does is, essentially, it says, hey, if I go to that specific URL, I expect you to respond with a certain message that's actually been dynamically served from console. So let's take a look at our test. So for this case, again, switching back and now running the third test. And obviously this will build our container, but it's basically empty. The only thing it has is an Alpine-based image, so the test will fail. It doesn't even have a command instruction. So in the end, it'll just tell you, hey, sorry, I can't create console because there's nothing that I could run against in this, because the command specified within Sinatra is empty. There's nothing that you can do. Now, that's not what I want to do. So, how does the test actually look? How does the Docker file actually look that we're going to write for this test? It looks like this. It's pretty much the same as before. The only thing that has changed is that we're adding a different example file. Now, let's go back and see what it actually does. Run a third test again. In this case, it builds the actual Sinatra Docker container before it does this. So every time you're getting a fresh example of what it's like building this container. You could also pull it from whatever repository you have. If you have this in a CD environment, obviously you're built by a CI. That's at your prerogative. In this case, I'm rebuilding it since I don't have a dedicated CD. So as you can see here now, I basically am running the example 3 test. It's creating the console container, it's creating the Sinatra container, and then it's waiting for both to come up, and then it should respond with this KV of hello from console. And then it's all done. It tears down the containers again, it's removing them, and then we have one test, 0 failures. And we actually have tested a connected setup with 2 different Docker containers. You can expand this to pretty much anything Docker Compose supports. You could also use Kubernetes. You could also use Amazon ECS. Whatever you want to have access to from this ServerSpec and is supported by Ruby, you can do. There are other things like, for example, you can extend this using Kitchen, if you're familiar with Chef already. You can extend this using Ansible. You can extend this using Salt. Whatever has access to and from Ruby, you're golden. Now, as I said before, there are other things that you can test with ServerSpec. This was really simple, just accessing a web URL or maybe determining whether a package was installed. You have things like testing for files, or you have things like testing for users. You can see whether a process is running within a container. You can see whether a cron job is actually implemented within the container. You can test for groups. You can test for different PIDs to be there. You can also write your own tests for certain resources. With the current project I'm on, for example, we wrote a tester, an actual artifact, which lets you see whether or not there is a valid SSH key within the container. And this is actually done using a cryptographic library from Ruby, which is actually validating if the key would be accepted by an SSH server. So this is something that you can do. The power is, it's up to you how complicated your setup needs to be, or how complicated you want it to be, but it's definitely possible. I talked about backends before. You have a lot of different backends at your hand, and I showed you the Docker backend today. There's also the SSH backend, which lets you use virtual machines, for example, or use different other clouds which don't have direct access via an API, but maybe via SSH. You can also use exec. So if you want to, for example, what we use exec for is testing Packer AMIs for Amazon. So we upload all the tests that we've written before for the AMIs that we want them to, which formulate how we want it to look like. And after Packer is done, it'll run these tests and verify that everything we have on this AMI actually conforms to the specs that we've written before. And as I said before, WinRAM is supported as well, so you can do this on Windows if you're into that. Now, I've only shown you a very, very small fraction of what ServerSpec supports and what InfraSpec in particular, or Spec Infra is capable of. I encourage you to visit these links and take a look at the software that I just showed you and what I introduced you to. All of this presentation will be online at the Git URL that is shown above, basically on my GitHub account. And I think the one module that I also mentioned before, this RSpec wait, is in here as well, because it's really nifty, especially if you're talking web development, or even just waiting for certain things to start up. It's very handy, and you can make use of it in your tests. And with that, this was a really small look into the world of TDD with containers. And with that, I'm pretty much done. I hope you have might have some questions, and I hope that you've enjoyed this presentation. Thank you very much. So, any questions? Yes, please. Sorry, I'll stand up now. I hope that's okay, camera.
Just was given a thing in addition, you could also see many good examples in Puppet. They follow the ServerSpec with the bigger part.
Excellent. Yes, absolutely. There are a couple of Puppet modules that make use of ServerSpec as well. It's true.
To have kind of
Anything else? Yes, please.
What do you would you suggest for the really software developers? Should they start to write the test in front of developing the software itself, or doing them after?
So do you ask that for infrastructure, or do you ask that for developing containers? So infrastructure, containers, or software itself? Because TDD has been around for quite some time. I'm not sure. So if I have to defend TDD right here, it'd be a very long session, I think. But yes, so I would have to say the benefits of writing these tests before you actually write your container definitions, I wouldn't have guessed that it would be that large, but with the current team I'm on right now, it's actually huge. It's tremendous. So we actually have a large sense of ownership within the team, not just from myself or somebody else who's also affiliated with infrastructure, but from everybody, because they're much more keen to writing these files, these Docker files or definition files, because they've written the test before. And they basically are saying, whatever I do, it won't break because the tests will also not run. So whatever I do, there are certain expectations which I've basically have written down before. And if I fail to comply with these specifications, then it won't run. And then I either have to fix the Docker file or be more elaborate with my tests. But all in all, it gives a more thorough sense of what it means to be responsible for infrastructure. And I think that's very good, especially for cross-functional teams.
Do you use it for pre-production to check your return?
So I have a very aggressive stance when it comes to environments. And we don't actually have a pre-production environment. We test locally, and we have what we would call a test environment, but it's only useful for things like showing something to a product manager and is dynamically torn up and down, and then we only have production.
You run it at the last mile before going to production?
Yes, exactly. Right before, so I mean, obviously it's also run within the CD infrastructure, so when we build the actual Docker images, the tests are run, but some of them are also run directly on production servers before they're actually live, just to make sure, okay, everything's okay. Yes?
Do you know if this works well if run from inside a Docker container? So of course I have to mount socket and so on, but does it generally work?
Yes, it does. We actually are running this in our CD infrastructure from within a Docker container. So the CD agent is actually inside a Docker container, which is then running another Docker container. There are a couple of caveats, like if you're using the same infrastructure outside of the container, so we had trouble with console, for example. We have a console server which is running on the same machine as the worker, and then we are trying to start some integration tests which are also using console. Then you have naming conflicts, perhaps. But that's easily resolvable. But apart from that, it works beautifully.
And you run it as siblings and not as Docker and Docker?
Yeah. I mean, I'm still not quite sure what Docker and Docker truly means. If it actually means starting a dedicated Docker container inside Docker. So because I've heard a couple of opinions on that. So what we're actually doing is we're just using the same Docker daemon on the same host to start all the other containers. Yes?
So the tests are written in Ruby. Do you know if there are other language bindings or?
So yes, the tests are written in Ruby because ServerSpec and Spec Infra itself both are written in Ruby. And for whatever reason, I don't know why, but a lot of these BDD-driven test frameworks, especially for infrastructure, are written in Ruby. And I know of some others. They're written in Python. I've forgotten the name right now, but I can, if you ping me, I can send you a link. But they're not nearly as featureful and don't have the same coverage as ServerSpec and Spec Infra. So unfortunately, if you want to go down this path, if you really want to try it out, then you will have to put up with Ruby, at least for this very small portion of what you're trying to do. More about the expertise. So I'm going to tell you right now, and I want you to try this, okay? Give it like I don't know, 24 hours where you try this out, because the language of Spec Infra and ServerSpec, this BDD-driven development, is actually quite nice and easier to learn than I think as if you were going to go about it and say, okay, I need to learn Ruby first and then going to go tackle ServerSpec. Try to tackle ServerSpec directly. Yes, with the more complex examples, obviously you will have to have some Ruby expertise, but at least to get started and get off the ground and just get a feel for it and see whether it's actually viable to go for it afterwards. Give it a try. I think you will be able to succeed at least for the very from the very beginning, and then maybe advance into more into other topics which will require some other knowledge. But
Problem is because as with test-driven development, developers themselves should write tests for the structure environment.
yes,
So every developer has to know simple Ruby.
yes, absolutely. That is the idea. So what I'm going to I mean the thing is, and this is a broad statement. This is my own opinion, but what developers, and I'm a developer as well, what we usually associate with being proficient is we know this inside out, right? I'm really proficient at something, so I can do it on the fly. It's fine. I probably know, I would say, 10 different languages, and I'm not proficient at any of them. None of them. I am still employed by a very reputable consulting agency, and I make quite a lot of money. So that can't be the problem. I think the problem is just being open to change and being open to maybe learning something different. And using ServerSpec, as I told you before, is not about learning Ruby. It's more about getting to know the approach, seeing whether it's viable for you, and if you're interested, you can pursue it further. And if this means that you might need to pick up some bits and pieces of Ruby, you don't need to be a Ruby zealot if you're going to use ServerSpec. Not at all. Then yes, this will actually entail learning some Ruby in the end. Please.
Can I comment on this? I'm a Java developer and I'm using ServerSpec for writing tests for my infrastructure, and I cannot write Ruby. But the documentation of ServerSpec is so good that I don't have this needs that I can write, that I have to write Ruby. Yeah? So try it and have fun.
There you go. I think that's a brilliant answer. Thank you very much.
Yeah.
Gauss is double as from Golang, some kind of similar concept written in things that it has a YAML syntax or something else.
It's a good pointer as well. Gauss, right? GOSS, as far as I remember. Yeah. Good thing. Again, not as featureful, but at least it's an approach, right? Please.
You've got kind of two levels of tests which you showed. You've got the ones where you just check this needs to be installed, these ports have to be open, and so on. Then you have more like integration or acceptance type tests where you test the whole system.
Yes.
Which one do you feel is more useful? Would you write both of them? Do you write as many of both of them? Do you feel the integration is better than the unit? Or, well,
That's always a good question. I think it really depends on your expectations, essentially. So if you want to treat the code that you write or the software that you write as a black box, that's fine, and you write an integration test, which essentially just tests a couple of endpoints, or maybe all of this spectrum thrown together into one. But especially for environments which other people have to rely on. So if you think of Docker base images, for example, images that you are creating, which are then used by other teams to have their applications on them, I would think it makes more sense to actually write more tests that satisfy expectations along the lines of this file has to be here, this file has to be executable, this file has to be has to have a certain checksum or whatever, instead of just saying if you run something on it, then it'll be responding on port whatever. I think that's basically the decision that you have to come to is how far down the rabbit hole do I have to go in order to satisfy the constraints that have been put upon me.
I kind of ask it because if you would be developing an application, you would write a test for some logic, and then within a function, you'd still have that logic, and your test would expect certain outcomes. While writing this sort of test often feels you just say, I expect this to be installed, and then you write a line, install this.
Yes.
And there seems to be less logic in the bit that you're testing. You're almost just copying the code, saying, I want this to be installed, and now
it's a very good and excellent point. I've heard this before. People say, it's basically tell me, hey, am I not testing my provisioning framework then? Or am I not testing something which is already being tested? With Ansible, for example, you have certain states which you can converge on, And you're basically, Ansible is testing already if a certain file is at a specific place or not. Why do I have to use ServerSpec to do this again? And I would basically tell you about it, or answer this question in this fashion. How do you know that Ansible actually does its job? Are you 100% certain? How do you know that Chef does its job? Do you want to risk your images or your Docker containers to be not viable, or not viable in a certain conditional sense, right? Maybe it works 98% of the time, and this 2% actually takes down your infrastructure. Or do you want to just make sure from the outside with a different system that it actually conforms to these specs? So I would say, yes, at times it might seem tedious to just write the same tests on either side, but there's so many ways of conforming to an expectation. So you could use apt-get, you could use yum, you could use Ansible, you could use Chef. So, and there's just, at the other side, it's basically just saying, I expect this to happen. How you're doing this is up to you. And if this works on the other side, is also up to you, right? So if Ansible works, that's great, but you just verified it. If apt-get works and installs the right version, cool, you just verified it. That's essentially, that's the kind of, so I think the trade-off of having to sometimes write these one-by-one lines towards being actually sure that you're going to deliver something which is verifiable and conforms to expectations, I think is much more in favor of conforming to its expectations. Anything else? All right. Thank you very much for your time. If you have any questions, don't hesitate to contact me. You know all my details. And yeah, have a great day.